Good morning, AP Calculus. I have a quick video today to discuss with you how to use your graphing calculator to find the derivative of a function at a point. The calculators will, in fact, do that. There are calculators out there that will find derivatives in general. For example, they would be able to tell you if you asked for the derivative of x squared, they would tell you the derivative is 2x. What we're looking for to do on our calculators and what the College Board requires you to use your calculator for on the exam is to find the derivative of a function at a point. So here we go. We're going to let our function be equal to x squared, because I know that you can do this in your head. So if we go to y equals, we got a lot of stuff from a long time ago. I'm going to clear all that out. And we're going to make y1 equal to x squared. Okay, so y1 is x squared, hit enter. And I'm using x squared because I know that you know the derivative of x squared is 2x. Okay, so we're going to go back to the main screen. So second quit to get out of there. And if you hit the math button just below the green alpha key, and if you look down at option number 8, you will see nderiv, which stands for numerical derivative. And when we hit that, you're going to see the familiar dd blank. All right, we want ddx, so you're going to put an x right there where the blinking a is. And what are we taking the derivative of? Well, I could put x squared in here. All right, I'll do that. X squared. Okay, and we're interested in the derivative of x squared when x is, well, let's just pick a nice easy number when x is 1. All right, now, if I asked you for the derivative of x squared at x equals 1, you would say that the derivative of x squared is 2x. And when x is 1, 2 times 1 is 2. So the answer should be 2. And sure enough, there it is. The calculator has given us the derivative of x squared at the value when x is equal to 1. Now you recall that I put x squared into y1. So if we go back to the main screen and hit math 8 again, math 8, it brings it up real quick, ddx, and you can have any variable here. The common one to use on the calculator is x, but you can use any variable that you want, doesn't matter. And I'm going to bring up my y1. So remember on y1, it's going to be alpha and then the trace up at the top there. And there's all my y variables, and I'm going to choose enter on y1 there. Okay, so it puts y1, and then I'm going to use the arrow to move over. I want the derivative of y1, once again at x equals 1, since y1 is equal to x squared. And there it is, the derivative of x squared at x equals 1. In other words, if f of x is x squared, what is f prime of 1? F prime of 1 is 2. Okay, and we can do this for any value. Math 8, all right, ddx, and we want y1, alpha trace, y1. What's the derivative of x squared when x is equal to negative 5? All right, we plug in negative 5, and we know it's going to be negative 10, and sure enough, there it is. Okay, so you can check derivatives at a point using your calculator. You can also find derivatives at a point, especially when the functions are rather messy. So go back to y equals, and let's clear out x squared, and let's get something much messier than that. So what if we had the sine of x squared, all right, plus 6x, and we were to multiply that by the square root, so second square root, and then underneath that we have x cubed, so we got x to the third. We're going to get out of the exponent, minus 8x plus 1. All right, and there's our function, and we want to find the derivative of that when x is equal to 3. Well, yuck. That's going to require a product rule and 2 chain rules. Okay, so and then we got to plug in 3. Instead of doing all that, let's let the calculator do the work. We've put this into y1. I'll hit enter to solidify it. We're going to get out of the equation editor. All right, and you know what? Just for shortcut, I'm going to push up twice because I have it in y1. I'm going to hit enter. That's going to bring it back down, but I don't want this at negative 5. I think I said I wanted this at 3. So I'm going to type in 3 right here. And the derivative of that messy function at 3 is negative 2.4687, blah, 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 blah. So here's what I'm looking for you to do. There's a sheet of paper in the yellow folder. Try those problems out and see if you can get used to doing the derivative on your calculators. Good luck.